Who am I? I'm Dennis Doomen. I'm from the Netherlands. I've been doing this work for about 28 years. I'm 51. I started programming on my Commodore 64 when I was, I think, 10 or 11. Um, I like to think I'm actually a coding architect. I'm mostly in the .NET C# space with a lot of, Vue.js, React, TypeScript, JavaScript, stuff like that. And my main job is to help software development teams optimize all the way from ID to production. So I talk about architecture, about test-driven development, which is a big thing I care about. Domain-driven design, I have a lot of experience with event sourcing. So pretty broad interest. And today I'm sharing some of my experiences. I work for a small firm that you don't care about because it's in the Netherlands. I'm an MVP, whatever that means. I have no clue how I became one, and I have no clue how I stay one. Because I'm not the best friend of Microsoft. I don't like Visual Studio, for example. I hate SharePoint. I don't like Teams. So I don't know. By the way, any .NET developers, just from my understanding, is not really relevant. Or Java? Okay. Oh, wow. Managers? No. All right. Enough about me. This is the biggest problem I see existing code bases struggle with. Coupling. Right? Everybody's struggling with coupling. Everybody starts, with this great architecture, nice pictures on the wall, of your architecture. Everybody's happy, and then you start building stuff, and developers come and go, and they make a mess out of it. And it's almost everything. Every time it's about coupling, being able to change one thing without changing something else, right? Everybody's struggling. The fact that you're here, hoping I have the holy solution for all your problems, which I don't. Says enough. So what do we have been trained to do to be able to solve coupling? What are the two solutions for coupling? I like to be interactive. I don't know if you noticed that, but yeah, no. Okay, I already have 40 minutes, so I'm not going to wait 5 minutes for the answer. We are trained to increase cohesion, whatever that means. So we're basically trained to put everything related to a particular complexity in one place and reduce coupling by introducing abstractions. In the .NET space, we basically take a class, create an interface in front of it, slap an I in front of it, and now it's called I something. It's stupid, I know, I've been doing it for 20 years. I accept it, but at least it's abstractions. You try to create some kind of interface or contract between the thing that you want to protect that is supposed to make it easier to decouple things, right? I don't know if you've heard about that, but there's this saying, I don't know who said it, it's probably very old. There's not a problem you cannot solve with another abstraction other than the problem of too many abstractions. Well, I have built my fair share of abstractions and interfaces because I love building frameworks, and it usually becomes really ugly and difficult. Because yes, our brain can only process an X amount of complexity, but if you add too much abstractions in front of it, the problem becomes rather abstract, difficult to come, that's the issue. Even though these are pretty decent principles that have been trained and you should actually follow them. But too many abstractions, I already said that. I don't know why my mouse is suddenly moving. It's not supposed to do that. But anyway, how do you increase cohesion? Sorry? Yeah, you put everything close together. What is a development practice that we all trained as junior developers that is supposed to reduce duplication and put everything in one place? What's this fundamental mantra? Dry. Which is not about not drinking alcohol or something, but yeah, don't repeat yourself, And that's very difficult. It's again a cool thing to do. But the problem with dry is that it actually leads to more coupling. Because if you're going to dogmatically reduce duplication and make sure every individual concept is in one place only in your code base, what will happen? Everything will depend on each other. And what do you have then? Coupling. So even though it's all cool stuff, these are principles that have been trained and it makes sense. And I see some older people in the room, they probably recognize all of this. But dry is a good thing, but it creates coupling. And that is something we try to avoid. It's almost like a vicious circle, you have to go through. So what is the solution? I don't know. Well, I do. Understand the internal boundaries. Understand the structure of your code base. Understand the seams that exist in the code base. understand the layers and slices that exist in the code base, and apply those principles within those boundaries, but not across them. And it's almost so obvious that I wonder, like, why did it take me 28 years to discover this? But I hope it makes sense if I talk a little bit about that. So this is the only thing you need to remember from this talk, other than I'm Dutch and I'm pretty small. Well, short. Understand the internal boundaries. Understand what the architecture of your code base is. If you look at a code base and you cannot understand that, you cannot actually digest it from, something is wrong. That's usually what I say. I've worked with code bases where developers were connecting all kinds of stuff, different layers together. And I was wondering, like, why do you actually in your unit test include that part of the code base, but not that part? Like, you are including the domain layer, but you're not including the other layer. Turns out that code base was using an onion architecture. But nobody in the team knew that because it was completely obfuscated. This beautiful architecture that the architect originally envisioned is completely gone, muddled by all the mess that we as developers create, including myself. So how do you do that? Well, you can actually look at the dependency on the architecture level, the package level, and the code level. I'm going to cover a couple of them. I completely forgot to start the timer, so I don't care about time. All right. First thing, solid. Who knows solid? Okay. And I'm not talking about food or anything, about these solid principles. Yeah. There's one principle, and I'm not going to repeat them because I don't know them. No. The D in solid actually means dependency inversion principle, which has nothing to do, not really, with dependency injection. A lot of people misunderstand that. It's the dependency inversion principle. What does it mean? And my point is that it's a principle that's so important that you should actually try to apply that same principle on the architecture level. So I have this, I know in the back it's pretty small because I sat in the back and it's very difficult to see, but I have this abstraction. Yes, it's a C# abstraction. I'm going to, because you can actually see the I in front of it. It's called I store order. There's a lot of Java developers, so you know the syntax. It's actually a generic interface. Has generic methods like I want to add an order or some type. I want to delete it. I want to be able to query for it. Right? It's a very simple thing. This is not going to be anything special, but the slides will be online, so you don't necessarily have to create pictures. Now, I have an implementation. In .NET, it's called an Hibernate. In Java, used to be called Hibernate. I think that's coming from. It's an ORM. It's something that's responsible for storing those orders in a database. I have a module called order processing, which connects to that. This makes sense. This is what you usually see, right? And the dependency go down. The order processing module, which is like a higher level thing in your system, is where the domain lives, depends on this abstraction. Now, there's a question for you. If you look at the bottom part of the code base of this picture, do you think that's very generic code or very specific code to what the system is solving? Who thinks it's generic? Who thinks it's specific? Who has no opinion or doesn't have a clue? The proper answer you're supposed to give is that it's actually very generic. It's usually also in the bottom layer if you have a layered architecture, in the bottom layer of your architecture. And if you implement that, it's usually also very difficult to optimize for the complexity. You don't know actually what the order processing module is trying to do. It may even send, I don't know if you know that, but in .NET you have something called link, which allows you to build SQL-like statements, and then the ORM will convert those SQL-like statements into actual SQL statements. So the top layer can do whatever they want, completely screw up the database because, yeah, developers don't know SQL unless you are a database developer. So this is a problem because the lower part of the system is very generic. And the thing is, over time, it will just become more generic. So what does the dependency inversion principle tries to do? It actually reverts the dependency. Almost the same interface now, I store order, same name, but the difference, if you can see, is that it actually contains really functionally specific methods that try to, it is a very intention revealing. They try to explain what that module needs. Now the big difference, the big surprise is this. So instead of the order repository being used by the rest of the system, it is now actually taking dependency on an interface. What's the real difference is the color. I don't know if you're colorblind, but the left side of the bottom part is orange, kind of, and the right side or the top part is pink, something like that. That's the point. The contract that defines what the order processing module needs is part of the domain layer, or whatever you call that, the business layer. So the dependencies go upward. That alone will create a lot of decoupling. Will make it a lot easier to optimize, because the order repository person that implements that, the guy or girl with all the SQL knowledge, they now know what you're trying to do. They now know that when you complete an order, you probably don't have to query for that. They might even decide to optimize the domain or the database structure so that these orders are removed to a different table, so that when you query for open orders, it's going to be very fast. You can actually optimize because you know what you're actually trying to do. That's a fundamental design principle that I try to use in my systems these days. But this is not an architecture pattern. This is a design pattern or design principle. Now, you can also take the same approach on the architecture. This is an example of the onion architecture. Has anybody actually used this in production successfully? I'm not saying you should do this. I'm just saying it's an option. Because, yeah, there's no single solution for every problem. Onion architecture basically says, like, you know, the core is the domain. This is where the business logic and the entities live. And if you're in the domain-driven design realm, you'll talk about aggregate roots, value objects, and that kind of stuff. That lives in the domain. The layers around that are application, domain services. I never understand or remember the exact differences. But it's very clear that anything that lives on the outside is usually what interacts with the outside. So like tests, the infrastructure, storage of data, the user interface, they live on the outside. Okay, what does that have to do with the dependency inversion principle? This. The dependencies go inward. So the domain model does not depend on anything on the outside. If it needs something, it defines an interface or contract that defines what it needs, and then the outside layers are going to implement that, which makes it a lot easier to test the whole domain model without the dependencies on the rest of the system. Right? Makes sense. And this is true. I've actually used this style a couple of times. It's not always that trivial, and it's never that beautiful as an architectural picture like this. But that's the beauty of abstractions, right? It's just a model. But it works. And it makes it a lot easier to keep your code base in check. This is an alternative version of that. Hexagonal. I should actually ask an English native speaker how to pronounce this. Hexagonal. But it's kind of the same idea. You see the domain is in the middle, the application is around it, the user interface, the infrastructure is on the outer layers, and they use different terms like primary, secondary ports to define contracts so that you can plug into that model. I prefer the onion architecture, by the way, or the alternative version, again, dependency go inwards, clean architecture, which is kind of the same picture, but you know, different terminology. Uncle Bob, Robert C. Martin has actually coined this one, but it's the same idea. Dependencies go inward. And if you actually go back to the original definition, the original definition of the dependency inversion principle is that higher level abstractions should not depend on lower level abstractions. And there's a reason for that. Things that are more domain specific are usually changing a lot less than all the generic code that you have, which sounds counterintuitive because my product owner changes their mind every day, you know, new requirements. But the reality is you make sure you try not to depend on code that's very generic, because what happens with generic code, abstractions of libraries and frameworks that you always build in every project, they tend to become even more generic because you have this natural tendency to reuse it. You know, we already have an implementation that knows how to clean up the database at the end of the, I don't know what. We're going to reuse it for other situations as well. And that usually means it becomes more complicated. This feels counterintuitive, I know that. If you don't agree with me, come to me afterwards, we can talk about it. So this is kind of the architecture style that I prefer to use. And the crucial element is here that I like to organize my code by functionality or capabilities. So I try to avoid technical folders. I try to avoid folders like repositories, entities, what else, views, stuff like that. That leads to pain and problems. In the .NET space, if you use like Visual Studio or one of the JetBrains tools, if you create a new project, you always get these technical folders. That's the first thing I rip away. I'm probably going to create some kind of template to be able to use in the community. But the point is, organize your code by functionality. And this is an architecture style, sometimes called a vertical slice architecture, where everything is grouped functionally. The boxes are important. The boxes are boundaries that I talked about, because I said boundary-driven development. For example, if you take this picture, you see 4 slices. There's something underneath called composition, which main responsibility is to connect everything together. So the idea is that every slice here is independent as possible. It does not depend on other things. If it needs something, it uses dependency inversion principle. It defines contracts of what it needs, and then the composition layer can connect everything together. Now, I wonder, some people will probably say, yeah, but wait a second, isn't that just, module-based development like we did 20 years ago? Yes, but old stuff usually gets a new name, and then, it's hyped, and everybody says we should do that. In fact, I don't know if you heard about this, but we had this whole phase where we were all adopting microservices because we want to get rid of these monolithic systems, right? And we were all very successful because, it was much easier to deploy, maintain microservices, version them, get everything, traceability of requests all throughout the services. It was pretty trivial. And because we were so successful, everybody's moving back to what they call a monolith, a modular monolith. A modular monolith, which is interesting, because it actually says that the monolith is not really that bad. And it isn't. Monolithical deployments for me is just the fact that it is deployed as one unit. It doesn't say it's a big ball of mud or spaghetti or whatever terms we use. I do that. I try to still structure everything really cleanly and try to control the dependencies, which is not obvious trivially. But so the composition connects everything together. Now, that also means that if you talk about dry, I just duplicate code. Really? Yes, I just copy-paste in the same code base, the same code like 3-4 times. But wait a second, that is like doing the opposite of dry. Yeah, that's true. I actually do that. I love it. I do it here as well. I just duplicate stuff. And I have helper classes. I love helper classes. In fact, if you're in a .NET space and you're a C# developer, you'll have extension methods, which I also duplicate. But wait a second, we have Sonar Cloud or Sonar Cube, and it's going to flag a quality gate because we have too much duplication. I said, well, I don't care. I like to decouple things. Why? Because I've experienced, and I'm not saying you should blindly follow what I've said. You would be stupid if I do that. But I've actually learned that if you duplicate code that is supposed to be reusable, quite often that duplicated code is much easier to understand and maintain than that reused code, because what happens, that reusable code usually becomes more complicated. Another parameter, because we need to use it in the 5th place, but we need some special behavior. Oh yeah, but we actually want to reuse 80% of that functionality, but we want to override some little bit of functionality. Oh, you know what? We'll make this one method virtual so you can override it. And then, you have at some point you have a whole hierarchy of classes and you're building your own framework that nobody's understand. Duplicate the hell out of it. It's totally fine. But do I always do that? No, of course not. That's why I have this blue box at the bottom. There are certain things that I don't want to duplicate because you need to have certain skills or experience or certain knowledge to be able to do that. Is there an easy way to say when I don't and when I do? No. You have to look at the individual situations. But yes, it feels very unnatural to do that. If you're pretty young, your senior developer says, what the hell are you doing? Duplicating code? No, we don't do that in this house. I do. And the interesting thing is, I do that by taking into account those boundaries. So I apply dry within boundaries, but not just dry. I do other things as well. Oh, by the way, there's a centralizer. I also use those same boundaries, those same boxes, as the default scope for automated testing. Wait, what? Yes. So my unit, by default, is not a class or a method, even though the books tell you. I'm actually trying to think for myself and try to understand what are the boundaries in my code base. Well, the slices are definitely boundaries. Are we talking about unit tests? I don't know. I don't care. It's a test. It's a very natural boundary in my system, a natural, say, scope for unit testing. I may actually do that. Of course, there's also other slices which I use, which are covered by tests separately. And within those slices, you of course have reusable pieces of code. I call them service here, whatever it is. I test them separately as well, of course. And there's another one here, and there's one at the bottom. So my general rule of thumb, if something is supposed to be reusable or designed to be reusable, then you have to test it separately. If something is just an implementation detail of a bigger thing, then I test it as a part of a bigger scope. So my biggest problem that I had, or biggest pain, is that I was practicing test-driven development. I've been doing this for 15 years. That I was creating tests which are way too small. So every time I was redesigning, refactoring code bases or parts of the system, I had to rewrite all these tests. That's a big smell. Of course, then you have the other architects that say, "Oh, we only test end to end." That's not the solution as well. We don't have this pyramid for nothing. But I tend to go a little bit bigger than most people go because it has proven to me to be very successful. All right. That is the architecture level. 15 minutes, okay. I'm on track. I know I speak pretty fast, and I'm Dutch, it's not even my native language, but if you go on the package level, or you could also call it component level, there's a bunch of principles, or maybe I should call it heuristics, because principles you're supposed to uphold and never deviate from, that will help you reduce coupling. And there's this picture. Whenever I build a library or package or framework or something like that, I always have a main package. Of course, there's a main package. But this is an important part. Who has built in this audience some kind of framework for the other developers in your team to be able to get things done quickly? Honestly, I'm actually disappointed. I was expecting almost everybody has done. I've built a lot of frameworks because I want the junior developers to be able to get things started quickly. The problem with those frameworks is usually they hide too much details. They hide the magic. They even behave like a magic. You're like, okay, you know what? In our code base, if you want to build a view, you just inherit from the view class, and suddenly all kinds of magic will happen. I don't like that anymore. I've built that myself, but I don't like it anymore. So what I do is, if I build a package, I have, for example, a .NET package called Liquid Projections, which is being used in the event sourcing world. And I thought, like, okay, if you have event sourcing experience, you have things like projectors. I just create a base class and you inherit from it, and suddenly all kinds of stuff happens. No, I don't do it anymore. Instead, I actually start with small blocks, which on itself have value. They're usually not used individually, they're used as a combination, but I want you to first understand the bits and pieces that are in the library. You need to understand what each thing is doing. And you know, when you have like tutorials and documentation, you start explaining those little bits and pieces. And when you understand that, then you're allowed some of the convenience classes that will combine, you know, common use cases into reusable classes. But you're forced to understand the details, because nothing is more annoying that you use a framework and something doesn't work as expected. And you have to drill down into the details, and it's completely unmanageable and ununderstandable. Because the thing is, a lot of people build frameworks where the top level thing that you inherit from is properly documented, but all the interiors are mess. And if you want to understand why your thing is not working with your library, you want to go into the details and also understand what's happening there. And I kind of force people to go the other direction. The other thing is, applications don't use inheritance. Although it's one of the basic principles of object-oriented programming, I don't like inheritance anymore. It doesn't mean I don't use it at all. It just means I like to, you know, I lean towards like composition. So I use a class or a framework, that's why I usually call them libraries, in my classes and my code, but I don't necessarily inherit from it. Because inheritance is a much more intimate relationship and more coupled than composition. So I try to build my libraries. And by the way, this can be just code within your code base. It doesn't have to be a library framework. It can be just a bunch of components and modules that work together. Also means that as long as that package only depends on more what you call shared packages which are abstract, have more abstract behavior, or are very stable, you also reduce this whole dependency hell thing. If you're in the JavaScript world, you pull in one npm package, and then suddenly you have a 10,000 line package log JSON, like you pulled in all the other dependencies, that's a problem. And probably in Java and .NET we also have that. It's not as bad as JavaScript, but this principle has helped me to reduce that, to reduce decoupling on the package level. So as long as you only depend on things that change less often than your package, you have less of a problem with this whole dependency. It's not going to be a way. It's not something that will completely solve it, but it reduces the chance. Abstract packages are things that only contain interfaces. And stable packages contain, classes or objects that are so simple they never have to change. It seems so simple, but it's a way of doing that. It means something else. If your package is supposed to work with something else as an optional dependency, then that main package should not support that. That optional dependency should be implemented by separate package, that has a dependency on the optional dependency and also on the main package. And that way you also keep them decoupled. Of course, if you use something like that, you still need to connect everything together. That's, the previous picture, what the composition layer is supposed to. That's where the knowledge is, how to connect everything together. This I think is going to be very abstract for a lot of people. But you can probably look at liquid projections. Even if you're not in the .NET space, it actually demonstrates how I apply that. And if there's something that you don't always use in the main package, like, I don't know, test steps or something, I put them in a separate package as well. So let's say you build a component that can interact with a certain database, and you want to have an in-memory version of that, for a mocked version that's very useful for unit testing. I don't put it in a main package. I put it in a separate package, because it's very stupid if you have to fix a bug in the test stub, and because of that you have to release a new version of your main package. Because I use semantic versioning, and then okay, I fix a bug, but it's only applicable to test code. It's not even used in production. So if the code that's in your main package is only used in the test environments, then don't put it in the main package. Keep it separate. But Dennis, don't you end up with tons of packages? Yes, you will. But fortunately with GitHub, it's all very easy to structure all that. I'm trying to look at your faces if it makes sense. I see a lot of... I get that. I always have that with my talks. It's probably my speaking skills. No. Now, if you go one level down on the code level, there's probably a couple of things what I always do. I don't know how it works in Java, but in C# you have this thing that defines whether a class or type is visible outside the project. You have public, private, you probably know that. In .NET it's called internal. So the first thing what I do is make things internal, which means it can only be used within the same DLL or project, which actually reduces the scope of that. Unfortunately, in Visual Studio and Rider, if you create a new type, it's always public by default, which is stupid because I don't want that. If you do it like that, the cool thing is if you have a good IDE, JetBrains has some pretty good IDEs, it will also try to detect hey, you actually made something internal. Now I can actually, as an IDE, do a full, a code-based wide analysis and figure out, hey, you're not actually using that thing. And since it's internal, you can just delete it. Well, my best day is when I can delete code, especially other people's code. But yeah. All right. Same here. There's all kinds of refactoring options. This is all Rider, JetBrains Rider, where I basically remove that code. Parameters, like in this case, you see, I don't know if you can see it probably in the back, there's a very light gray method in the lower right corner. That's not being used. I just delete it because I know I can trust for that. That's why I hate JavaScript, because you cannot rely on that. TypeScript is a little bit better. You can actually delete code because the compiler understands that everything still works. What's another good great thing so that you know that everything still works? Automated testing. Just to check who's actually using unit testing and stuff. Who has a code coverage more than 90%? 90, not 19. See, 80? 80%? 70? Okay, I'm not going to ask anymore. Test-driven development, anybody then? Just checking? See, these are the cool people. All right. And again, another one, very difficult to see, but there's a parameter that's not being used. In fact, this is interesting. This is a picture of a parameter called bool include private is false, which basically says it's like a default parameter value. My IDE is telling me, you know what, you defined a parameter called include private, which default value is false, and I've scanned your entire code base, and you never actually call this method where the value is true, so you can just delete it. That is useful, but you need to have a good IDE and a language that supports that. That's why I love type languages. I already mentioned earlier, I want things to be structured in a functional way. So this is an example of code that is designed to be reusable. This is a piece of code that is there to support distributed locking. Like I have this application that is deployed in Azure, runs in multiple web apps at the same time, so it's scaled out. The first one that starts needs to make sure that the database schema is initialized or updated. So I need some kind of distributed lock. There's probably stuff in Azure that can do that, but we also needed to be able to use this outside Azure. And what you see is we have this method like top level folder called infrastructure, which is probably somewhere in this blue bar we saw earlier in the picture. We have a functional folder called distributed logging, which has a method, the cluster-wide log provider, and an interface, C#, sorry, I provide cluster-wide log. That's kind of a trick. Like we actually use the word I, of the letter I, as a way to say, I'm a contract and I provide you with a cluster-wide log. That's the implementation is the provider. Everything else is in an internals folder, which is very puristic. But what I'm trying to do here is to make it explicit that that code is not supposed to be touched or not supposed to be reused. Even though if you look at the names and you're a little bit in the .NET space, you might think, okay, that sounds pretty reusable, but it wasn't designed for that. I don't want you to reuse that. So I make it very explicit within internals. I think in Java it also works. You can actually do an enter and then it includes a piece of code using, I don't know, namespace kind of things into a different folder. In .NET, it's like if you want to use it, you type a name, the IDE will tell you, oh, I know this class. It's in a different namespace, and you can include it. If you do that, you'll probably be including stuff like infrastructure.distributed-locking.internals. Hopefully that will trigger a discussion in your code review, if you do code reviews, obviously. But this is an example where I really try to be explicit about what belongs together. It also means that folders that live next to each other in the code base are almost their own little boundaries. So this was definitely boundary, distributed locking. It's its own little boundary. Even though there's multiple classes there, I also treat them as one boundary and test them as one boundary. Same here. Folders that live adjacent next to each other in principle should be treated as their own little boundaries that you probably should use as much. Also, apply dry unit testing at the same way. This is a different way of looking at it. Tell, don't ask, very old principles. You see like if order.orderlines.any has a value which is higher than 10,000, then the order is high valued. What's wrong here? Could be one line. Now that's not going to make it better in my opinion. Yeah. Now the problem here is that apparently as developers, we decide, we have this order class, let's say, assume it's an order class. We decide outside that order what defines a high valued order. Wait a second, I thought we have these things like data hiding, encapsulation. So tell, don't ask is actually saying, I just want to know if this order is high valued. How you determine that? That is logic, that's an implementation detail that needs to live inside the order class. That's what the tell, don't ask is. Tell them what you want, don't ask all the little details that you want to do. The law of Demeter is similar to that. See, you can see like how many dots do you see? In the back you see none, I know. I count 1, 2, 3 dots, although the last one is a character. The rule of thumb in the law of Demeter is if you have more than 1 dot in your statement, you're doing something wrong. You're probably, interrogating the internals of a class. In this case, we have a context, whatever that means. It's probably a class or an interface. I'm asking like, okay, give me the selected member path, and then I'm going to do a count on that. Why are you doing that? Why do you want to know how many dots are in the selected member path, which probably is a string? That's another example. Instead of, maybe you want to know the depth of something. You know, the fact that we use dots to represent that, that's an implementation detail. So whenever you have more than one dot in your statement, ask yourself like, okay, am I violating the law of Demeter here? Again, it's a heuristic. It's not always the case that you're violating it. It's more like be aware of it because it reduces coupling in your code base. Link in C# is a fluent API. And if you in the .NET space and you do unit testing, you may have heard of fluent assertions. That's my little library. Fluent APIs are exempt from that rule. What happened? The guy on the other room actually hijacked my screen? See? I don't mind. I did this talk without a screen a year ago or something. Okay, it's working again. See? This is the other law of, you know, if something can go wrong, it will go wrong. That's the one. Yes, it's not part of. Yeah, this is the same example again. I already showed you this earlier. That's also one of the things why I like to encapsulate primitive types into more, let's say, domain-specific objects. For example, here I have an order, but I also have an order lines. Again, it's not visible in the back. So instead of that, my order has some collection type containing has all the lines of that order embedded into it. I like to actually create a custom class that represents a collection of orders. So instead of that, the order class itself iterates over the orders in the list that it has and makes some operations about it, I basically delegate that. That's a very simple technique. It's same with like, if your code base needs an ISBN number because you're a book tracking system, we usually use a string field or something to put the ISBN number in it. And then we have all kinds of logic to verify that the ISBN is correct. Why not create an object like a value type or value object that encapsulates this ISBN? That's a very logical way. It's again encapsulating and hiding data so that you don't have to distribute the knowledge all over the place. Okay, interesting question then. Say I have implemented this ISBN number or this ISBN type. Do I now need to use it all over my code base? Yeah, you paid attention. Good. No, you shouldn't, because maybe one slice of your system is about, you know, tracking and registering books, and it needs to validate and make sure that that ISBN number is correct. Maybe the other modules or slices in your code base don't care about it. They just need to have an ISBN number so they can present it or display it somewhere. They don't care about the validity. And this is a mistake I made. I introduced value objects and then started to use them everywhere, which creates coupling, which is what we try to avoid. So maybe the general rule of thumb of this talk is don't reuse stuff unless you really have to. Think about it yourself. I have about 7 minutes left. Yeah. Sorry? I started at, oh yeah. So, okay. So what did I do? Usually when I want to understand the design, I look at the folder name, I look at the dependencies, the namespaces in .NET, for example, to try to build this mental picture. I use tools to visualize those dependencies, which also help me understand it. By the way, the thickness of the arrow actually indicates how close, how more connected it is. Type diagrams, which are completely unreadable, like this one is also an example that you can use. That helps. Use your IDE. Great IDEs allows you to navigate through the code base, understand, you know, who overrides this particular method, where values are coming from, examples, even like, you know, the whole call chain you can analyze. That will help you how things are connected. I even use AI tooling these days to explain code, especially if it's complicated. There's the AI assistant in JetBrains, but also use Copilot a lot. And if it's legacy code, then that's probably the only thing. This is my typical flow, and I deal a lot with legacy code. I love legacy code because you can delete a lot of shit. The first thing is I understand the production environment. I try to understand how is the thing put in production? What are the connection strings? What are the things that vary in that production? How do you actually deploy that? That already gives me so much information about the system. You know, then I actually go into the code base and understand it, as I just showed you. Then I try to find all this dead code and delete it, because the less code to understand, the less to maintain. Then I build a safety net. I build temporary automated testing also called characteristics test, that create a temporary safety net so I can refactor things and still know everything works. And then I make sure I have a deployment pipeline. I automate everything using infrastructure as code. I start to improve the code quality and improve the code design and ultimately improve the architecture. That's a flow. It's quite difficult. It sounds so simple if I draw it, but this is my job generally. But this is the flow I go through. We're out of time. There's not even time for questions. So I'll be around for the rest of the conference. I'll definitely be at the party tonight. Ask me questions. Approach me, because I love to talk about this stuff. And usually I don't do this in 40 minutes. I spend the whole day on this, which nobody likes. I'm very happy that you're here. I hope you enjoy the rest of the conference. And thank you for your attention. So don't forget, understand those boundaries. Find the seams in your code base.